Alright, today we're going to talk about using rates, ratios, and proportions. We're going to start off with some definitions. Hang in with me. First definition that we're going to talk about is a ratio. We have four definitions to talk about. So hang in with me when we talk about ratio. A ratio is a comparison of two quantities using division. A ratio is a comparison of two quantities using division. The next one we have is rate. Rate. Alright, a rate is a ratio that compares quantities measured in different units. So a rate is a ratio that compares quantities measured in different units. Then we have a unit rate. A unit rate. Alright, a unit rate is a rate whose denominator is 1. So we had a rate and we made the denominator 1. That makes it a unit rate. Finally, we have a proportion. Proportion. A proportion is an equation that shows two ratios that are equal. Alright, so you can see how all of these relate. A proportion is an equation that shows that two ratios are equal. Well, we use these all the time and we don't even know it, so let's do one example to see how we could use these. Which is a better deal? 3 boxes maybe of cereal for $4.50 or 5 boxes for $9? Alright, well let's take a look. We have $4.50. Alright, we get 3 boxes. If I want to know how much each box costs in this case, I would take $4.50 and divide it by 3. That's 1, 3, 5, so 15. So each box here costs $1.50. Alright? Now in general, the more boxes you buy, the better deal you get. And so, let's check to make sure. Here's 9 boxes, or $9 gives me 5 boxes. What I'm doing here is I'm finding the unit rate for each one. So 9, 5. Add a decimal there. It can go in once. That's 5. That's 4. 0. And that's 8. So here, one box costs $9.80. So I would say the 3 boxes for $4.50 is actually a better deal. And you can see that I could actually buy 6 boxes for $9. But if I took this deal, I'd only get 5 boxes for $9. So, again, you can see that that's a better deal. That's how we would use the unit rate. That's sometimes how we can do it. So whenever you go grocery shopping, you can compare the price to a half a gallon versus a gallon. If the half a gallon is less than half the price, then you're getting a good deal. If it's more than half, then the gallon's a better deal. Alright, a race car driver drives at 120 miles per hour. What is the rate in miles per minute? Well, we have 120 miles per 1 hour. Alright? I wanted to convert to miles per minute. Now, we've done some things like this. I want miles, so miles can stay, but 1 hour equals 60 minutes. So I want the 1 hour on top, because 1 hour is on bottom. It allows me to cancel it out. 60 minutes. I can cancel out my hours, which you can then see is 120 miles in 60 minutes. Alright, so that's miles per 60 minutes. And now I need to make it back into a unit rate, so I need to divide. I'm going to go ahead and cancel out these zeros, which gives me 12 divided by 6, which equals 2. So he's going 2 miles every minute. 2 miles per minute. Sometimes we're just given a proportion and we need to solve. You've probably done these before, and if you remember, we did cross multiplication. So you would go 9 times x is 9x is equal to 12 times 6, which is 72. I would then divide by 9, and x is equal to 8. Alright, so that's how we can solve proportions. The reason we can solve them by cross multiplying really is because of this. What I do is I multiply both sides by both denominators because I want to cancel them out. So I'm going to multiply this whole thing by 4 and 8. And I'm going to multiply this side by 4 and 8. Remember, the property of equality allows me to multiply as long as I do the same thing on both sides. So here the 4 cancels out. Here the 8 cancels out. So you can see we're multiplying x minus 5 times 4. And here we're multiplying 1 times 8. That's why it works. Now here we have 4 times x minus 5 equals 1 times 8. I'm going to use the distributive property here. So that's 4x minus 20 equals 8. I'm going to add 20 to both sides. And 4x is equal to 28. So then if I divide by 4, x is equal to 7. So that's how we solve them. Even if we have maybe a larger term up here on top, it means we have to use the distributive property. Well, I hope all of that makes sense. I know we kind of flew this pretty fast, but again, like always, have any questions, let me know. Have a good evening.